Good afternoon, everyone. Sorry for the little hiccups here at the start. Thanks for taking some time out of your busy day and spending it here to learn about some of the new capabilities we have in the simulation space for SolidWorks users. And thank you to the Javelin team for scheduling this session. So my name's Omar Zoni, and I'm joining you guys today from San Diego. I've been with SolidWorks for about 11 years. Before that, I worked at ANSYS and Northrop Grumman, and so I've been in the simulation space for longer than I care to admit. Sorry about that. So a couple housekeeping items. I believe everybody is muted. So if you'd like to ask questions, at the bottom of the Zoom kind of GUI, there should be a Q&A spot, and you can ask those questions. My goal is to have enough time at the end of this to go through some of those questions, so we'll get to them at the end. And if there are issues with video or audio or kind of general housekeeping things, you can use the chat, and I believe Aaron from Javelin is going to be monitoring the chat. So here's the agenda for today. We're going to start out by explaining what SimaliaWorks is and how it fits into the SolidWorks portfolio of tools, and most importantly, what it means for you guys, right? So then I'm going to show a workflow demo so you can get a feel for what the SimaliaWorks interface looks like, how it integrates with SolidWorks. We'll then cover some advanced capabilities. So the structural mechanics engineer applications, that's based on, this will become a little bit more clear as we go into it, but structural mechanics engineer is kind of the highest level SimaliaWorks tool. And then we'll discuss some next steps if you guys are interested in next steps. So, all right, so let me start by introducing Simalia. So I don't know how familiar you guys are with kind of the way Dassault is set up. And, there are times I work at Dassault and I'm not sure that I'm all that familiar. So basically, Dassault is broken up into brands. So I know that you guys are familiar with the SolidWorks brand. The SolidWorks brand, is basically the CAD, the PDM stuff, in your desktop simulation, electrical, Composer, those products. The Simalia is another brand inside of Dassault Systems, and Simalia is basically responsible for the development of all of the simulation tools that Dassault has either developed or acquired. So even the desktop SolidWorks simulation tools are developed by Simalia. The plastic injection molding software, I don't know if any of you guys use that, was a company that we bought called Simpo. That's also developed by Simalia. So this slide basically represents the acquisitions over the past, say, 20 years. And the reason why I show this is I want you guys to understand, like, the commitment that Dassault Systems has to simulation runs very, very deep. We're very serious about this. And, so you see acquisitions around, finite element analysis. Arguably the flagship product within Simalia is the Abacus solver. And that acquisition was made, about 15 years ago, give or take. You also see tools in here for magnetics, acoustics, topology optimization. Just in like 2016, they acquired CST for electromagnetics. They acquired XFlow for CFD, a Lattice Boltzmann CFD tool. They acquired Wave 6 to do vibroacoustics. So these acquisitions, the reason why I show this is, again, I want you guys to understand the commitment runs deep, and it only makes sense for SolidWorks, the largest CAD package in the world, to start leveraging some of the capabilities available from some of the other brands within DS. I know that SolidWorks, and I'm guilty of this too, sometimes we get really, really hyper-focused on what SolidWorks can do, and we don't want to kind of look outside of that space, and we've been guilty of that. And I think that it's hurt us in the past. So if you kind of break simulation up into the main building blocks, these are probably the 8 main ones that if you talk to most simulation people, and you can see that Simalia has solutions for all of those. So what exactly is SimaliaWorks? Well, let's start by looking at how we have traditionally broken up the simulation space. So we basically said that, depending on the level of difficulty, or not the level of difficulty, but kind of like what hat you wear. On the left, you've got designers that spend most of their time in CAD packages. On the right, you have people that spend all of their time doing analysis. And then you have, simulation solutions that we provide on the vertical scale. So the first 4 that just popped up are basically what's available in desktop. And I don't love this slide necessarily, because I do think that if you're using SolidWorks Simulation Premium, there are some really advanced things that you could do. And I should say that we're just focusing on structural analysis right now. Then on the right, you have Abacus CAE, which is arguably the most powerful simulation solver in the world on the FEA side. The way it handles contact, nonlinearity, its material modeling, it's very, very complex. That being said, it's really, really difficult to use. The interface is just a little bit challenging, let's say that. So Simalia Works is basically a product that's built on the 3DEXPERIENCE platform, and I'll talk a little bit about what that means, that is bringing in capabilities from Abacus. So it's using the Abacus solver, and it's got an interface that's really, really geared towards SolidWorks users. So a much more intuitive user interface. The way it integrates with SolidWorks is much more intuitive. So what is the goal? The goal was basically to accomplish a few things. Well, probably more than this, but the three that I would argue are the most important, especially if you're a SolidWorks user who has struggled with some of those more advanced simulations, is to provide you a powerful, reliable, robust solver for complex models. So models where you've got a lot of nonlinearity, high strain, complex hyperelastic materials, ill-conditioned contact problems. And Abacus is really just well suited with that. Obviously, we realize CAD is kind of everything revolves around that SolidWorks CAD. So it's got to be integrated tightly with your SolidWorks model. And in addition to being powerful, it's also cloud-based. So if you wanted to not run your models locally, you have the option to run in the cloud. So purchasing cloud credits that allow you to run on virtual machines that sit out in the cloud that get access to 18, 36, or 144 cores, depending on the size of your model. So it really, really can expand your simulation capabilities. And again, I mentioned that it was on the 3DEXPERIENCE platform. I'm sure you guys have heard about that. If you've been paying attention to Dassault and SolidWorks, you know that the 3DEXPERIENCE platform is basically an interface or a workbench where multiple different, a lot of different job functions can come to share ideas and collaborate, right? And I feel like I think SolidWorks has been pretty guilty of not adopting the 3DEXPERIENCE platform. One thing that we've learned this year, as we all struggled to get through this pandemic, and a lot of us are still working from home, is that we need to be able to work anywhere, and we need to be able to collaborate, share ideas, work across functions easily. And honestly, this year has been really eye-opening for a lot of us at SolidWorks in that aspect. And I'm sure a lot of people are struggling with that right now. So the 3DEXPERIENCE platform is really a place where you can leverage some of the changing dynamics of the workplace, I would say. So just to give you guys a bit of a feel, I'm going to focus really on structures right now. So on the left, you have the SolidWorks solutions for structural analysis, computational fluid dynamics, and plastic injection molding. These are the roles that we're going to talk about today. There is also a Simalia Works tool for computational fluid dynamics and plastic injection molding, and I don't think there will be more collaboration between SolidWorks and the Simalia brand in the coming years. So I wouldn't be surprised if you see some really advanced topology optimization, generative design, magnetic solution, more powerful flow solutions are definitely something that we're talking about, system modeling, acoustics, all those kind of things. So it just makes, it just makes sense to leverage those capabilities in the SolidWorks community, which again, it's the largest CAD community in the world, right? So I'm going to gloss over that one, and I want to get into a workflow demo. So what I'm going to do first is I'm going to show you guys an example of a very, let's get into it. So recently we were approached by a company that does modeling, and they have a group of industrial designers that they said they wanted to be able to do a handful of tests. So, and basically this is what their test setup looks like. So at least for the first group of tests. So they wanted to be able to do linear statics, linear buckling, And then they wanted to be able to do crush and drop testing. So this is basically showing you what the setup would be like for a crush test, right? We're going to fill this thing with, I'm saying with liquid here because we've got some really compelling capabilities inside of SimaliaWorks that allow you to model a fluid inside of a bottle using what are called smooth particle hydrodynamics. So they wanted to do a crush test basically. So let's go ahead and take a look at how that would work. So this is basically how the demo is going to start. We're going to, pull in our SolidWorks model. I'm going to use Structural Designer. Structural Designer is the SimaliaWorks tool that's kind of just, it's the linear analysis kind of tool. So very similar to like a Sim Pro or a Sim Standard, but it's using the Abacus solver. We're going to run our linear statics or linear buckling. I'm going to create a duplicate of that, and then I'm going to go over to structural mechanics, and I'm going to show you how to set up and some of the results that you would get for the crush test. And then I'll show you guys a little bit about how to organize and share results. All right, so here we are. The first thing I'm going to do is I'm just going to go ahead. This is the 3DEXPERIENCE platform. I'm going to import my SolidWorks assembly. So very, very quickly, I can import the assembly. Now, the nice thing about this is it's not a dumb import. So I'm importing it, but it's linked to the SolidWorks part and assembly. So if I make a change to the SolidWorks part, there will be a SolidWorks refresh button that shows up here on the platform, and I'll be able to update it. So I've brought in the geometry. Now I'm just saying, look, I want to run a linear structural validation on it. It's going to ask me what type of analysis. Let's start with the structural, just kind of applying a force. So again, this is the really simple, not low end, but kind of linear product. So I'm going to specify some mesh settings. Again, this is kind of meant for someone who spends most of their time doing design. I've turned on adaptive meshing, which means it will remesh if it sees a lot of error. For this example, I'm going to remove the top and bottom plate and just kind of focus on the bottle. Now, there is a material library that comes with the software. I'm going to show you guys a little bit later a really powerful thing called material calibration that allows you to take test data and fit it to a model. But in this case, I'm just going to assume that this is a plastic material. I'm going to pick PET, and I'm going to go ahead and apply that onto my bottle with just a simple click of the button. I don't really have to worry about contact or connections in this case. The example when we do the crush and some other examples, I'm going to highlight contact because it's one of the real compelling features and reasons why you might want to start using a tool like this. For the restraints, I'm just going to make the very simple assumption that it's fixed at the bottom, so it can't move at all. And there are other restraints that are available, but just for something quick, I'm going to go ahead and use that. For the loads, I'm just going to say that there's a load applied on the top, and I'm just going to pick that top face. You can see this bottle is really thick. I did that because we're going to come back in and change the thickness to make it much thinner. I'm going to apply a 10-pound force. And really, that's all I need to do to set up this model. Again, it's a relatively simple model. I'm using solid elements, which is all that's available in this particular product. The kind of a linear product. You can see I can specify whether I want to run it locally or on the cloud. Non-interactive typically isn't used. And I'm just going to say, look, I want to run it locally using my resources, and I want to run it as quickly as possible. So I'm going to go ahead and say, okay, it's going to go ahead and generate the mesh, prepare it for simulation, and it should solve relatively quickly. It will go through and refine the mesh. I had the adaptive meshing set to 2, so it'll run it once, look for areas where you've got high strain error, and rerun it. So let's just let this guy finish. And yeah, so really, really quickly, we're able to get results. You can see right now I'm looking at the von Mises. I can, obviously you've got a whole range of customization things that you can do with respect to how the results are viewed. So that's a little animation of what it looks like. Again, don't get too caught up in the reality, how realistic this simulation is. I just wanted to kind of show you guys what it looks like. So obviously we can animate, show the high and lows. There are a lot of other kind of cool things that you can do with respect to visualization. So I'm looking at von Mises stress here. But if I wanted to, I could look at things like, displacement to get a feel for exactly how much it's displacing, reaction force vectors to get a feel for exactly where the force that I'm applying is being reacted. And then this is a nice compression tension plot to get a feel for what areas are in compression versus tension. So very quickly, we were able to set up and run that example. Now, they also wanted to run a buckling analysis, right? So I'm going to go back to the geometry. I'm going to say, look, this time I want to run a buckling example. Setup is going to be pretty much the same. So I'm going to go to my parts. I'm going to turn off the two bodies that well, first I'll put on my mesh. I'm going to go ahead and remove the parts that aren't needed for the restraints. I'm just going to clamp it at the bottom. And for the load, typically when you're running a buckling analysis, you would put just a 1 unit load, and then you get buckling multipliers, basically. So you're multiplying whatever value you get times whatever load you put on. In this case, I'm putting on that value of 10. So whatever buckling factors I get, load factors, I'm going to have to multiply by 10. And I'm asking it to pull out 10 buckling modes. So again, I'm going to go ahead and simulate this. It'll run very, very quickly, and then we'll be able to take a look at the buckling modes. So that's probably not one that's going to be excited. That's probably not one that's going to be excited. That's probably the one that if you applied a 10 Newton load on would be excited. So now, if I wanted to, I can go back to SolidWorks, and instead of using that really, really thick value of 0.1, let me decrease it by a factor of 10. I'm going to go ahead and save it. And now if I go back into the platform, well, yeah, okay, so we can see that it's thinner. Now if I go back into the platform and go back to my setup tab, click over, we can see that there's that SolidWorks update button. Normally it would be grayed out if there were no changes to the model. I can say update, and it's going to go ahead and automatically update the geometry. So this is one approach that you can use for linking to your SolidWorks model. There's also a PLM strategy that you can use that gives you a little bit more revision control. But yeah, and you can see I don't have to reset anything up. Everything is already set up. I would just have to go ahead and rerun this. So now let's take a look at, let's say now, so we're pretty comfortable with the, the buckling and the linear static analysis. You can see both of those listed there. Let's say now I want to create a copy of one of those so that I can run some more advanced analyses. So what I'm going to do is, I know this, it just looks different than SolidWorks, and a lot of times people can see this, and it can be a little bit intimidating. It's using another brand. So the 3DEXPERIENCE platform leverages a lot of different brands that are available from Dassault Systems. This is using the Innovia brand, which is kind of the PLM brand inside of Dassault. I'm just making a copy of that model so that I can run some advanced analyses on it. And now let me just pull up some of the results, and then we'll talk a little bit about the setup. So this is the crush test, and I've modeled it a little bit differently. I'm actually modeling this with shell elements now, and I'm using the explicit solver that's available inside of inside of SimaliaWorks. So it's the Abacus Explicit Solver. Now what's interesting here is I don't have to manually specify any contact pairs. The way Abacus and SimaliaWorks handles contact is through what's called the general contact setting, and it basically makes the assumption that anything, whether it's touching or not touching, is a no penetration contact. And obviously you can change that if you want to tie it together. You can see that that's the utilization of SPH elements. So the bottle was partially filled. You can kind of see where those dots are. So you model it with a volume, then you say that that volume is going to be SPH elements. And yeah, then you can model. So you can model some really, really cool, compelling types of physics. So that's the mesh that's being used. You don't see kind of the vertical on the top and bottom because I'm using shells. So it's only the top face of the bottom part and the bottom face of the top part are what are meshed. You can see what another nice thing is now we've got access to different element types, right? So these are brick elements. I can use parabolic or linear bricks. If you're using a hyperelastic material, there are H elements that are available here. There's some reduced order integration elements. There are a lot of bells and whistles that, depending on the type of analysis you're doing, we can do just a lot more. So and in this case, actually, an FDO3, which is the kind of like a service pack, which was just released. Now we can do axisymmetric analysis. So I could have modeled this as axisymmetric. So you can see this is the general contact. I'm just saying, look, all surfaces are basically a no penetration, and I can specify the friction coefficient that I want to use. So in this case, I'm using a friction coefficient of 0.1. And let's go ahead and take a look at how you could share and collaborate with other people. So here are some other examples of models that I've solved. So there's also the ability to, there's kind of like there's a 3D Play app, or the Simalia simulation review, which is kind of like the oh God, what's the app that's available for sharing like data from SolidWorks? The name's escaping. I'm having a senior moment, but it's basically a way that you can kind of share, results on the platform. So you don't, you can kind of get an instantaneous look at some of the results. So here we're looking at the same model that we had just set up. You've got access to, change things. You can mark it up. So if you wanted to share this with like your boss, or, someone, maybe you're the analyst and there's an industrial designer and you want to, share some information about what you're seeing as the analyst, so that maybe he could potentially change his, industrial, his design, right? So it's really easy to share data on the 3DEXPERIENCE platform, especially. So the way it's set up is there are basically tenants. Each individual customer would have their own tenant. You can invite the appropriate people to the tenant. You can create kind of workspaces for different projects and invite the relevant people to all of those workspaces. So yeah, I mean, it's a very, very powerful tool. All right, so let's take a look at some more advanced kind of applications that you can run using. So the product, for the first two analyses, that was a product called Structural Designer. For the last one, it was a product called Structural Mechanics Engineer. I honestly hate talking about product names. I feel like it's our job, as a consultant for you guys, for you to tell us kind of what you're trying to solve, and for us to provide you the most economical and robust offering that we have. So I try to stay away from product names. I feel like it's insulting for us to assume that you guys are just going to know what the products are. So these are kind of the types of analyses that you can run with using Structural Mechanics Engineer. So I would argue that the highlights are the Explicit Solver, which really allows you to model those short duration, high energy kind of events. So impact, drop testing, what I just showed you with those crush tests. On top of that, there's also the ability to do damage modeling. I'll show you guys some videos that explain exactly what damage modeling is. You can also do, the SPH elements if you're doing fluids, or if you've got something that could potentially explode when it hits something. So, a lot of times SPH elements are used to mimic like a bird strike if a bird is hitting an airplane. A wing or any aerostructure, and the bird's kind of going to explode. A little bit gross, but a lot of times that's what's used. And you can see a lot of this stuff is things that you could also do inside of SolidWorks. So there's some overlap, but for the right kind of problems, this is a slam dunk. And there are a lot of problems that you just would not have been able to solve inside of SolidWorks simulation. So I also want to highlight the material calibration app. So I don't know if any of you guys have worked with like material test data, but if you do, so you can see this is a uniaxial test data. This is some uniaxial test data where I'm pulling it into the material calibration app. And then I can basically say, look, I want you to fit that data to a material model. In this case, I'm saying a hyperelastic material. You can see all the different hyperelastic material models that are available. Let me slow this. This is a video, so let me just slow it down a bit. So you can basically execute, and what that does is it iterates and it changes these variables that define the behavior of your hyperelastic material model. And it keeps iterating on those until it finds the best fit. So this is the curve fit data, and this is your actual data. The dots are your actual data. So it will continue to run until it finds a good fit. And then you can, if you wanted to, you could switch to different material models to find out which one has the best fit. This one looks pretty good. The other thing you can do is you can actually look at the stability range for the material. So, ooh, sorry about that. So in this case, you can see that typically with hyperelastic material, you have uniaxial, biaxial, and planar data. They're probably the three most common. Often there are sometimes when you'll have volumetric and simple shear data also. But this is telling me basically that for the biaxial stability rate, it's not stable for strains of 4, which is 400% or larger. So if that was, a strain rate that you thought you were going to be operating in, you could go back and say, look, I want to, pick a different material model and ensure that it's stable in that range. And then obviously, you can export this material model and use it in the platform. So very, very powerful. I think SolidWorks simulation had some of this capabilities, but it certainly was not as powerful as this. All right, so here are, some more examples of just types of analyses that we can run now using the SimaliaWorks tools in the 3DEXPERIENCE platform. So this is that I know this slide is busy, so let's kind of walk through them one by one. This is that bird strike analysis using SPH elements. So you can see this kind of cylindrical projectile, I guess, is meant to mimic a bird, and what's going to happen when that bird strikes. Whatever it's hitting there. Metal forming, something that, can be very, very difficult because of the level of plasticity involved, something that we can achieve now. Blow molding, very, very simple using the SimaliaWorks tools. You guys saw this one that was the bottle crush. We can now do damage modeling, which allows us to basically specify how a material is going to behave beyond the ultimate stress. So after ultimate, right, the material can start carrying less and less load until finally it can carry no more load and it kind of just breaks apart. That's something that we can now mimic, albeit it's difficult to get that material data sometimes, but if you've got it or can approximate it, it's something that we can do. Impact testing, drop testing. Here's a bottle drop with, SPH elements on the inside. Imagine trying to do this wire crimping analysis in SolidWorks and having to manually specify all of those no penetration contacts. Which faces could potentially contact. You don't have to do any of that with the SimaliaWorks. You just say, look, all of these faces could potentially come into or out of contact with any other face. Twisting, here we've got, another example of complex contacts and buckling. So again, how would you specify what faces are going to be coming into contact throughout that? It would just be very, very difficult. Crush testing, riveting operations. This came from a airline company that had some issues with their riveting and wanted to ensure that their rivets were going to be safe. So we were able to run that using SimaliaWorks. So let's just take a minute here and talk about some next steps. And I am not a sales guy, so I don't want to put on a sales hat. All I'm going to do is tell you guys where you can get some more information if you're interested. If you go to solidworks.com/SimaliaWorks, there's a lot of great content available that talks about exactly what you can achieve with these products. There are some customer testimonials. We did some work with a company called InFocus a couple of years ago, and they were able to do some really, really compelling things. We did some work with GE. Insilixa, there's some really good customer testimonials because, I feel like it means a lot more coming from a customer that's actually using the tool than it does, from someone internal to DS. So check that out. If you're on my solidworks.com, you can also go there and search for Simalia or SimaliaWorks, and there's a bunch of content there. A couple examples that I've actually worked on. Some really cool examples. So this is a bellows structure, and this is kind of a honeycomb structure that goes through buckling and some really, really wacky contacts. So those are a couple really cool examples. And yeah, there's also technical training that's available. So if you do purchase, you know, there's some really good training that's available. This week I'm doing a training with our South American. The last couple of weeks I've been doing training with our South American partners. So with a lot of excitement about the products in South America. So at this point, I think I am going to turn it over for question and answers. So this is my email address. I know sometimes as engineers, we don't like to ask questions in public. So if you guys want to fire me an email off or look me up on LinkedIn or whatever, feel free. My name's Omar Zoni. I will look at some of the questions here. Yes, it's eDrawings. You could share results with eDrawings. Thanks, Carl, for correcting my senior moment. Another one, are there any plans to make a SolidWorks package for the Mac platform? So there is a SolidWorks connected right now that's actually on the 3DEXPERIENCE platform that I believe does not require an install. And all of these, the 3DEXPERIENCE stuff is on the cloud, so you can actually should be able to utilize them from anything, right? Like from whatever device you need to use. So I don't think there's not gonna be like a desktop for Mac, I don't think. So let's see, any other questions? Just check out the chat. You guys are quiet. I don't see any fatigue capabilities. Carl, that's a really good thing that you point out. Actually, fatigue is coming in FDO4, which is going to be available in January. So yes, fatigue will be there. And it's going to be using, I think the fatigue tool that Dassault acquired was a product called FESafe. So it'll be a subset of the capabilities available in FESafe. And yeah, there's a lot. There's also going to be a much tighter connection with your SolidWorks models. So you're going to have access to all of your SolidWorks parameters. If you want to do like a parametric study on the platform, that's going to be something that's going to be very easy to do in the next release. There's some really powerful lattice boltzmann capabilities. There's a product called XFlow that you're probably going to see us talking about at SolidWorks. We're going to be talking a lot more about magnetics. I mentioned SPH. What's the key difference from conventional CFD? So SPH basically takes a solid body and breaks it up into smaller particles. So those particles can interact with one another, but it's not a CFD analysis. It's not solving like the Navier-Stokes equation. It's basically looking at the behavior of those, the behavior of a fluid volume or something that can break apart as smooth particles. So it's just a different approach. It's a nice way to look at things like sloshing. There's also the ability to do like fluid cavities. So if you've got like a volume that's got a fluid cavity inside of it and you want to account for the fluid pressures, that's also something that you can do. Sure. So there's a question about the compute credits. So right now, if you purchase a SimiliaWorks tool, you can run on 4 cores locally. That is going to be changed to 8 cores, also in FDO4. So if you want to run on more than 8 cores, what we have right now is you purchase what are called compute credits. So I think they're a few $100 and you get about 8,000 credits, and they are consumed per hour of use. So the way it works is if you've got them, and I forget the exact numbers, but I think it's about like 500. If you've got a model that's less than 1 million nodes, it uses about 500 compute credits per hour. And it will solve that problem on an 18-core virtual machine. If you've got 1 million to 4 million nodes, it will use 36 cores, and it's about 600 compute credits an hour. And if you've got over 4 million nodes, it uses 144 core virtual machine, and I think it's about 700 compute credits an hour. Same if you want to run locally, if you've got a supercomputer. So you would need the compute credits to be able to run locally. Now, another thing that we're going to be introducing is what's called a simulation token. I don't know if anybody's used Abacus in the past, but tokens are not consumed. Tokens are checked in and out. So if you've got a supercomputer that you want to be able to use all of the cores on it, a better approach than buying credits because they're consumed is going to be these simulation tokens, which allow you to run for a certain amount of time. It's going to check out the token and then it's going to check them back in. And I think that's coming in FD04 also, or FD05. So that'll be Q1 of next year. But that's how compute credits work. It's really meant for utilization on the cloud, although you can use it locally. And the nice thing is, I know like SolidWorks flow simulation, SolidWorks simulation, we always talked about, being able to run on multiple cores, whether or not, for no charge. This is actual high performance computing. So if you've got a model that's taking, let me just say you've got a million node model that's taking 18 hours to run on a 1-core machine. If you submit it to the cloud on 18 cores, it's going to take basically 1 hour. There's going to be some time lost for transferring data up to the cloud and back, but in general, the solve time is very, very linear. Very linear. Can you solve multiple studies simultaneously? That is a good question, and I don't believe you can. You can set them up to run batch. Well, I take that back. If you're utilizing cloud compute credits, yes, you can. You can, because that's a non-interactive session. So you can submit something to solve. You can actually close that out. It's going to be solving on the cloud. You can go work on another thing, start that one solving, submit that on the cloud. But if you're running it interactive locally, then you can't. You can set it up batch so that it will run multiple solves. So yeah, if you want to run it on if you want to run multiple solves, you've got to utilize cloud compute credits and non-interactive running. So you've really got to run on the cloud. All right, guys, any other questions? Okay, well, like I said, here's my email address. Feel free to look me up if you guys have any other questions or something pops up. Like I said, I used to work at ANSYS, so I realize they're one of our competitors in this space. If you want to know how this compares to some of the stuff that ANSYS has, feel free to ask. I'm not going to make stuff up. I'm going to be as honest as I can. So, or any other questions about capabilities in general, just let me know. I'm happy to answer any questions. And again, thank you to Javelin. Thanks, Aaron, for putting this together. I hope it was useful.
Thank you, Omar. It was great.
Yep. All right, no problem. Thanks, guys. Have a nice rest of your day. Everybody stay safe out there.